Let me show you how to solve the basic blocks sliding along level floor problem, right? So they give you a block, and they say a 5 kilogram block of wood lies on a level floor, and there's a coefficient of static friction of 0.57 and a coefficient of kinetic friction of 0.32. Okay, and they want us to calculate the kinetic and maximum static friction between the block and the surface. So let's figure this out, right? The force of friction is equal to mu times something called the normal force. Well, if you're on a level surface, what's going on here is that you've got the force of gravity pulling down on this block, right? Okay, that's going to be a force of 5 times 9.8. Okay, and then of course the surface, being a good self-respecting surface, is going to push up on this object with a force equal to that. Okay, assuming that it doesn't accelerate into the surface, or the surface isn't pushing it up, accelerating it up, right? So these guys are equal but opposite. Okay, and then along this surface we could apply some force like this, right? And if it slides that way, there's actually going to be a little friction force this way, and that's what we're calculating here. Okay, now the normal force, technically speaking, is this guy, and then this is the weight, really. Okay, but ultimately this formula on a level surface breaks down into force of friction is mu times m times g. Okay, so let's just bust this out. The maximum static friction, okay, this is as high as it'll go. Now it'll be anything less than this, but it won't be higher than this, is equal to mu times m times g. So that's 0.57 times 5 times 9.8. And that equals, let's turn on my calculator, 0.57 times 5 times 9.8. 27.93. This is what we expected. That's the static friction, right? Okay, and now let's figure out the kinetic friction. Okay, all we do is we figure out, we just do the same thing, right? Only we use the kinetic coefficient, which is this guy. If you forget kinetic and static, remember it's always harder to start something going than it is to keep it going. Okay, so this guy is mu times m times g, right? And that's going to be 0.32 times 5 times 9.8. Okay, so 0.32 times 5 times 9.8. And we never have to calculate these again in the problem. We just do it once. And we might use it for all the parts of the problem, as we will here. Okay, so we've got our forces of friction. This is the force. If we want to slide it at a constant speed, we have to exert exactly that force. If we want to actually make it start moving, if it's stopped, we have to exert a force equal to or bigger than this, or something like that. Okay?